I'm going to go over the following homework problems with you. Numbers 15, 17, 19, 32, and 33. This is from homework number 20, section 3.5. I'm going to first do 33 and then go back to the other ones. So here we go. We need to find the second derivative by implicit differentiation. That means that I've got to first find the first derivative. I am going to ddx both sides of the equation. The derivative of 9x squared with respect to x is 18x. And then I separately differentiate over the addition. Now the derivative of y squared with respect to x, I need to make sure that I recognize y as a baby function using the chain rule. Blah squared, derivative is 2 blah. Give mommy her baby, and then multiply by the derivative of that baby with respect to the x variable. That completes the left side. And then on the right, we take the derivative of 9, the constant, with respect to x and get 0. To isolate dy dx, I subtract 18x and then divide by 2y. So simplified, I have negative 9x over y. And there's my first derivative. To find the second derivative, I'm going to ddx this. So I'm going to ddx the dy dx, and the other side of the equation, I'm going to be ddxing the simplified version, negative 9x over y. So the derivative of dy dx with respect to x again is the second derivative of y with respect to x. And then I'm going to I'm going to quotient roll the right side. So low d high. Low d high derivative with respect to x of negative 9x is negative 9. Low d high minus high d low. The derivative of y with respect to x gives me dy dx. Square the bottom and away we go. But we don't go because we need to write the second derivative in terms of x and y. So we need to substitute what we already know dy dx is equal to, negative 9x over y, into the dy dx and then simplify. So I have negative 9y, two negatives make a positive 9x, multiplied by, again, dy dx is negative 9x over y. And then divided by y squared. As I simplify, I can see that I need to get a common denominator. So I'm going to take care of that quickly by just going times y divided by y. And now I have negative 9y squared over y plus, wait, negative times a positive. Let's make that. Okay, great. Now it's just going to be like this, isn't it? All right, I will rewrite that. Oh, I've got my big eraser on. That's why I have a problem. All right. So I have negative 9y squared over y minus 81x squared over y squared. That will give me negative 9y squared minus 81x squared all over y squared. And that's going to wind up bringing the numerator's denominator down to the denominator. So y squared times y will give me a y cubed. But I'll bet that textbook simplified it from there. So I'm going to distribute a negative 9 out, and that's going to leave me with y squared plus 9x squared. And then I'm going to go back to the original equation and look at the fact that 9x squared plus y squared is equal to 9. So they really did do that. This got substituted with a piece from the original equation that said that 9x squared plus y squared was equal to 9. So this simplifies to negative 81 over y cubed. Wasn't that lovely? All right. Now I'm going to go over number 15, and I'm going to make some room for it. Okay. To find dy dx, I am going to need to ddx both sides of the equation, and I'm trying to get that not in the mix. There we go. So I am ddxing the left side, and I am ddxing the right side. As I take the derivative of the left side, I want to see that I have e to the power of something. So I need to chain rule this, and x over y is my baby function. Derivative of e to the bleh is e to the bleh. Give mommy her baby, multiply by the derivative of that baby. So right now, I need to take the derivative with respect to x of x divided by y. To do that, I'm going to quotient rule low d high minus high d low, and d low is the derivative of y with respect to the x variable, which means basically just dy dx. Low d high minus high d low, square the bottom, and away we go. On the other side, I'm taking the derivative with respect to x of x minus y, separately differentiate over the subtraction. Derivative of x with respect to x is 1, minus derivative of y with respect to x is dy dx. Now, I'm going to erase this down here so that I can focus on what I have. And in order to isolate dy dx, I am going to have to distribute. Let me find a good highlighter. I need to distribute this multiplication of the e to the x over y over this subtraction. And while I'm at it, I need to distribute the divided by y squared as well. So I am trying to distribute all of that through at once. Before the subtraction, I have a y and then over y squared times e to the x over y. And I'll simplify that in a moment. Minus, and now I have an x over y squared times a dy dx. That also needs to be multiplied by e to the x over y. And now it's just a couple steps away. And this is really bugging me, so I'm going to rewrite it as 1 over y. All right, now dy dx shows up here and here. I need to look at what is dy dx directly multiplying with. This dy dx has taken all of that. This dy dx is lonely. I need to get those on one side of the equation, whichever side I choose. So I am going to have all the dy dx's on the right side. By doing that, I'm going to add x over y squared times e to the x over y times dy dx. And I just changed the order of multiplication. No big deal. Minus dy dx, but I need to then subtract the one over to the left where I have e to the x over y divided by y. Now I need to factor the common dy dx out. And then divide. So I'm going to get that dy dx is equal to this lovely bit. And you probably want to see how that simplifies, so I will go ahead and take you through the simplification. If you don't need to see it, you can just fast forward. And I need to get a common denominator of the denominator's fraction. And I'm going to save myself a little bit of time by going cancel one of the multiplications of y in the denominators of the two fractions. So now I can write this as just e to the x over y for the numerator, and in the denominator I have x e to the x over y minus y squared over y. And I can multiply by the reciprocal because of what I'm showing you. Nighty-night. And now I have a y times e to the x over y divided by x e to the x over y minus y squared. And that should be the simplified version that the textbook has. If not, whatever. That's a good simplified answer. So that was that problem. Now I'm moving on to number 17. Okay. I need to ddx both sides of the equation. For the left side, I want to see that I have the square root of blah. I have a function inside of the square root. So I'm going to start off with the mommy function is the square root of blah, or blah to the 1/2 power. Derivative of the mommy is 1/2 blah to the negative 1/2. The chain rule says give mommy, not right now. The chain rule says give mommy her baby and then multiply by the derivative of that baby. And so I need to product rule with x times y. So I'm going to keep the x multiplied by the derivative of y with respect to x, plus derivative of x with respect to x times keep the y. On the other side of the equation, I start off with the derivative of lonely 1, 0, plus, and then I'm going to product rule x squared times y. So I'm going to keep the x squared, multiply by the derivative of y with respect to x, plus the derivative of x squared times keep the y. All right, I'm going to erase this work down here that was just there to show you what we were doing. And I am going to have to, over this addition sign, distribute this multiplication. And how about before I distribute it, I rewrite what is there. I can rewrite this piece as 1 over 2 times the square root of xy. So as I distribute that over this addition, I'm going to wind up getting that times x times dy dx. I'm going to save myself a little bit of time and just go like that. X times dy dx. Plus, as I am distributing again, I have that this is 1 over 2 root xy, and then multiplied by y. All right, now I'm in a good place. I need to look at where my dy dx is. And then I need to look at what is directly multiplying to dy dx. And I'm going to isolate those on one side of the equation, take the other things to the other side of the equation. So that gives me, how about I move this over to the right? So I'm going to keep the y over 2 times root of xy right here. And then I'm going to subtract the 2xy. And then I will keep the x squared times dy dx where it is. I'm going to subtract this beast over. And then I may want to deal with a common denominator while I'm working all this. So with common denominator, okay, come on. Work with me. Work with me. There you go. I'm going to take this and divide it by 2 root xy and multiply it by 2 root xy. So now I have y minus 2xy times another 2, making this 4, and then times root xy. On the right side, I'm going to factor out the dy dx. And that's going to leave me with an x squared minus x over that common denominator that I'm going to need to create. So I'm going to multiply this x squared. Get this moved over just a touch. I'm going to multiply and divide by 2 root xy. And then my numerator is 2 times x squared times the square root of xy minus x. Now I can multiply both sides by this denominator, and it's out of the way. And I'm dealing with y minus 4xy times root xy. And then finally, I will divide. So I have y minus 4xy times the square root of xy divided by 2x squared times the square root of xy minus x is equal to dy dx. And I'll have to check later to see if that is what the textbook simplified to, but that is good there. All right, on to 19. Again, we need to take the derivative with respect to x, and I need to get this cursor out of the way because it is annoying me. There we go. All right, I'm going to ddx both sides of the equation. And when I see the left side, I want to notice that I am multiplying two separate functions together. So I have to begin with product rule. With the product rule, I am going to keep one, multiply by the derivative of the other. The derivative of cosine x is negative sine x, and because it's with respect to x, that's all we've got. Continuing with the product rule, I'm going to keep the cosine x, and I'm going to multiply by the derivative of e to the y. But this is with respect to x, so I need to see the y as a baby function and chain rule it. So what I really have is e to the bleh. The derivative of e to the bleh is e to the bleh. And then the chain rule comes along and says, give mommy her baby and multiply by the derivative of that baby with respect to the x variable. And that is the completion of the product rule for the left side. On the right side, I take the derivative of lonesome 1 and I get 0 plus. Then I have the sine of x times y. I need to first see that I have a function inside of sine. So I need to take the derivative of sine of bleh using the chain rule. The formula for derivative of sine of bleh is cosine of bleh. Give mommy her baby and multiply that by the derivative of that baby. And I'm running out of room, as I'm sure you did on your homework. Ha ha ha, you're welcome. And now I'm taking the derivative of x times y, product rule. Keep the x, multiply by the derivative of y with respect to x, plus differentiate x with respect to x to get 1, and multiply by keep the y. I'm going to just kind of rewrite this to see better what we are working with. Actually, I'm going to put that exponential in front. So I have negative e to the y times sine x plus e to the y times cosine x times dy dx equals. And I need to distribute this multiplication over this addition. So I'm going to do that right now as I'm rewriting. That means I have x times dy dx times the cosine of xy plus y times the cosine of xy. And I'm getting close to done. Find the dy dx's. Look at who they are multiplied with and have those on one side of the equation. So I'm going to keep my x cosine xy times dy dx where it is at, and I'm going to subtract over to the other side my e to the y times cosine x times dy dx. And then on the left, I have negative e to the y times sine x, and I need to subtract this over. I'm going to pull a negative sign out of that mess. And I'm going to factor dy dx on the right side out of what is there. And what is there is x times the cosine of xy minus e to the y times cosine x. And all that's left is a little bit of division. So I have this negative sign here. I have e to the y sine x plus y times the cosine of xy divided by and if I were to take this, so this could be an answer. If I decide to do it, I can take this and go voila. And if I want, reverse the subtraction order. Same thing either way. And then last, but certainly not least, number 32. I'm going to get rid of what I have down here with 33. And I'm going to make it a big eraser. It will let me. Come on. Hello. Hello. Big eraser. Okay. This time I'm going to remember to stop having a big eraser. Oh dear, I've got stuff down there that I can't get to. There we go. Erase. That's what I was doing. There we go. Whee! And I'm going to bring it back to small eraser before I forget this time. Okay. Come on. Let me erase that. Okay. It's not letting me. I don't want you to delete that. I want you to, there we go. All right, sorry about that. Hopefully you fast forwarded through that. If not, now you realize you should have. Okay, here we go. I'm not even going to try to pronounce this. Look up pronunciation of it, and you'll find someone who can pronounce it properly pronouncing it for you. All right. We want equation of a tangent line at a particular point. So to do that, we have to first find dy dx. And I'm going to emphasize that this is our equation. To find dy dx, I need to ddx, both sides of that equation. with respect to x, I take the derivative of y squared. That means I need to see y as a baby function if it's not who I'm with respect to taking the derivative. So I'm taking the derivative of blah squared. I get 2 blah. Chain rule says give mommy her baby and multiply by the derivative of that baby with respect to the x variable. Then on the other side, I just have a function in terms of x. So derivative like normal with power rule, 3x squared plus 6x. And that means dy dx is equal to 3x squared plus 6x divided by 2y. I want to find the slope at the point 1, -2. So plugging 1 into x will give me 3 plus 6, 9. Plugging -2 into y will give me -4. So I've got a lovely fraction. For equation of tangent line, it is going to be y minus the y coordinate of the point, -2, is equal to the slope that was found, -9/4, times x minus the x coordinate of the point, 1. And that would give me an equation of that tangent line. That's part A. Part B wants to know at what points does this curve have horizontal tangents. Horizontal tangents will occur when the derivative is equal to 0. But when I've got a fraction, the derivative will be equal to 0 when the numerator is 0, but also the denominator needs to not be 0 at the same time. So I'm going to first look at what makes the numerator equal to 0. I can factor 3x, got an x plus 2. And that means that my solutions are x equals 0 and x equals -2. But how do I know what the denominator 2y is with those x values? In fact, I was supposed to find the points where I have horizontal tangent lines. That means I need the y that goes with it. So I need the equation back. The equation being y squared equals x cubed. I'm going to write that down. Pick another color. Y squared is equal to x cubed and plus 3x squared. Okay. When x is equal to 0, I plug 0 into these x's, and I get that the y value can only be equal to 0 at that time. That creates a problem because that means I have a 0 over 0 situation. I'm going to have to look at this a little bit closer. Before I do that, I'm going to look at the x equals -2. When x is equal to -2, I plug that in and I get the equation y squared equals -8 plus 3 times +4. -8 plus 12 is going to give me +4. This gives me two values of y, which means I have 2 points where I have a horizontal tangent line based on just x coordinate -2. So I am going to write those points down. I'm going to come over here. And so for part B, I have when x is -2, y is 2, and we also have y is -2. So it looks like these are those points. But I still need to analyze what's going on at 0, 0 to figure out if I have a horizontal tangent line there or not. So I'm going to go back to my dy dx, and I'm going to look at it a little bit more closely. One thing I can do is I can take the equation and I can substitute that in. Now, there are actually two equations going on if I isolate the y. So if I isolate y, I am getting both positive and negative, the square root of x cubed plus 3x squared. And I'm running out of room on here, so I'm going to bring up my whiteboard and try to move some of this over. Okay. Are you ready to write, whiteboard? No, you're not listening to me. Come on. There we go. I'm going to be working with dy dx being equal to 3x squared plus 6x divided by 2y, where y is equal to plus or minus the square root of x cubed plus 3x squared. Okay, I have that way too thin. Oh my goodness, that's why I've got it at a very low percentage. Okay, so I should look at two equations, but I'm going to temporarily just look at the positive version of that square root. Now, be careful. I'm concerned with what is going on when x is equal to 0. That means that I need to determine what is the limit as x approaches 0 of this derivative. And actually, while I'm here, how about I just start doing some factoring? So if I look at the numerator, I can factor a 3 and an x out of that numerator. And that will leave me with an x plus 2. In the denominator, I have my 2. Under the square root, I can factor out an x squared, leaving me with x plus 3. And now I have the limit as x approaches 0. Now be careful, technically the square root of x squared is the absolute value of x. Right now I'm just going to put down x, and I've already got to deal with the negative issue anyway, so I will look at what happens with this positive versus with this negative. So I do get a nice lovely little cancellation of these x's, leaving me with limit as x approaches 0 of 3 over 2 and I no longer have 0 over 0. I can now plug 0 in, and that will give me 3 times 2, which is 6, over 2 times the square root of 3. I can simplify that. I can simplify that more. So the slope, at least for the positive root, is root 3. However, I do have a second function that is going on. And so it looks like I've got a positive root 3 slope as well as a negative root 3 slope. Let's take a look at this graph to see why we are getting these two different answers. I have a Desmos already prepared. Here is the graph. Isn't it pretty? If we look at 0, 0, we see that this non-function, this relation, actually goes through that point twice. One of them would be when y is a positive value, or when y is dealing with the positive square root, I should say, and one when y is dealing with the negative square root. And with the positive square root, I am getting a positive root 3 slope. And I actually prepared these little tangent lines. So I have the tangent line when I'm going through that point at one moment versus going through that point at another moment. And now let's take a look at, we have 2 points where we have an equation of a horizontal tangent line. And we found those to be when x is negative 2 and y is equal to 2. Also when y is equal to negative 2 for that x coordinate. There they are. Then I have ready the equations of the tangent lines. Since the slope is 0, the equations of those tangent lines are only y equals 2 and a y equals negative 2. Isn't that fun? I think it's fun. And that is the final bit of that homework. I hope you enjoyed this session. Bye-bye.